Hello guys, I am the host Tekmaraj here, and this video we will be talking about that why we can't still achieve nuclear fission. So let's just start it. So I hope you would have liked my new intro. If you have liked, then please press the like button below. So why we can't achieve nuclear fusion till now? So what is nuclear fusion? Many of you know, but many of you don't know. So there is two techniques for generating nuclear energy. One is nuclear fusion and the one is nuclear fission. So in nuclear fission we have achieved that and we use it. In nuclear fission what we do is that we take an atom, a radioactive atom which is very unstable. Why radioactive? Because they are unstable, and we bombard a neutron in it, and when the neutron strikes the atom, it breaks and it gives so much heat and energy that we can use it to produce so much of electricity. But why we can't achieve nuclear fusion? So in general, nuclear fusion is a very reverse thing. So in what nuclear fusion we do? In nuclear fusion we combine two atoms. In nuclear fission we break atom. In nuclear fusion we combine atoms. Sorry, I am confusing a little bit. So in nuclear fusion we combine the atoms to form energy, and you won't believe, but nuclear fusion gives 10 times the energy of nuclear fission. So if you have nuclear fusion, it's more powerful. You need less nuclear fusion than you need nuclear fission to generate the same amount of energy. But why we can't use it, and why we are not using it, and why we can't achieve it? The main reason why we can't achieve it is the temperature, the pressure, and all the requirements which we have. So in nuclear fusion we need such a high amount of heat energy which we can't achieve till now, and it's more or same as the energy in between the core of the sun. We have to generate such high amount of heat energy to start the reaction, and then the pressure. We need so much pressure that we can combine two atoms together, because we are doing it on an atom scale instead of on a normal scale. So actually this is not that we can't achieve these requirements, but the thing is, if we put on that much energy, it needs electricity, okay? So every reaction needs electricity. For nuclear fission you first provide energy, then it's provide more energy than you are providing it. But in nuclear fusion, because we still haven't achieved that much technology, we will have to apply such a great amount of energy that the energy which is coming is less than the energy which we are providing. So we are getting a loss. In nuclear fission we are getting a profit, while in nuclear fusion we will get a huge, tremendous amount of loss, because the energy which we are providing is much more than the energy which we are getting through nuclear fusion. That's the reason why we are not using it till now. And many companies are open about how they produce nuclear fission reactions, because even if you just copy the fundamentals that this company is doing this to achieve this much temperature, this much pressure, and such a low electricity, still you can't just do the same thing so easily. You have to do so much calibrations and so much things. But we are the scientists are still searching the best possible ways to get this much energy in the best possible way, in the least energy provided. Okay, and this is like the same concept like a generator. If you want to power up a generator, you first swirl around that handle. You are giving mechanical energy, it converts into electrical energy, it starts the generator. After it is started, they don't have to do this again and again. It just keeps on going and the energy is produced. So the same concepts apply on nuclear fission and nuclear fusion, in which you have to provide electricity first, you have to provide energy first to start a reaction. Okay, but you can't do that like we are giving, if we say, okay, the nuclear fission reaction needs such a huge amount of electricity, temperature, and pressure that I can't just tell you guys that. But in a small concept, if we just talk about in normal volts, like you just imagine you have adapter. Okay, it says give 5 volt, and it will give you okay, let us say it says give 10 volts, and then it will give you energy. You can say okay, let's try. You're giving it 10 volts and it's giving you only 5 volts. So you are giving it extra 5 volts, which is costing you money. So that was a very bad example, I know, but still this is the thing, that we are giving more money, that is more than the money you are getting in profit. So this is the main reason that why we are not still achieving nuclear fusion, because it's very difficult to achieve. And even if we achieve, the amount of energy, the amount of money which we are investing is much more than what we are getting in back. So we are not getting any profit. Why our company would get in loss? But many companies are still investing to contribute to this technology and finalize it. And so these are the main reasons why this is not achieved till now. But scientists are working and many companies are working to achieve this technology, and we hope that in future we will have that technology to give us 10% more energy. And why nuclear fusion is more efficient is because the byproduct on nuclear fusion, the byproduct is mostly we combine hydrogen atoms. It gives helium. Hydrogen, it's in supplement amount, it's all over around us, and helium is not harmful to us. While in nuclear fusion we give radioactive elements which are very hard to dispose, and they are causing bad things to Mother Earth. So we can just use more nuclear fusion than we use nuclear fission, and because it's 10 times more powerful, we get much high amount of energy without destroying our Mother Earth. Okay, so nuclear fission is very good, but we still have to achieve it. It's very good and it's very powerful. So thank you guys for watching this video, and I'm your host Tech Modern, signing out. Like the video, subscribe to the channel, and press the bell.